force. So electrostatics topic, concepts here of electric force. Just to run through these, there are no calculations in this video, but it's been noticed that electric force, we either attract or repel. If we have two objects and they both carry positive charge, we'll get a repelling force. If both objects carry a negative sign of charge, we'll get a repelling force. If one charge is positive and the other charge is negative, we'll get an attraction. So if it's what the objects are carrying a positive charge, carrying a negative charge, we'll get attraction of the two charged objects. We can have different sizes of charge. There's another concept video that talks about the charge numbers. The size of the force, the electric force, depends on the charge that's present for each object, and it's proportional. So in a situation, suppose we have two charged objects, we get a certain force. Then if we would replace one of the charged object with a different object that has 3 times the amount of charge, we would find that the force is 3 times greater. If we replace with a charge that's 7 times greater, then the force becomes 7 times greater. So the force is proportional to the size of the charges. Then the size of the force is related to the distance. For the electrical force, if the distance increases, the force decreases. So they're inversely related. If the distance increases, the force will decrease. And it's not just inversely, but it's inversely proportional to the square of the distance between the objects. And I'm glossing over a little bit here of what happens when objects have a finite size. But we're going to talk about just very small objects where the radius is negligible, and we'll be measuring distance between those two kind of point charges. So an example of this, we have two charged objects and the force is a certain value. If we would move one of the objects, or both of them, but if we end up with a situation where the distance is 4 times larger than at first, the electric force will be decreased by 4 squared. It'll be decreased by a factor of 16. If we would make the objects 7 times further apart, then the force would be weaker by a factor of 49. You have to divide the original force by 49 to find the value of the new force. This is put together in Coulombs Law from the late 1700s in the studies that Coulomb performed. He wrote down, this came to be developed, the magnitude of the force is a constant, and for standard metric units, this value of K is very close to 9 times 10 to the 9th. It's easy to remember. I'm not going to write down the units, but in standard metric units it would be newtons times meter squared divided by coulomb squared, but just 9 times 10 to the 9th. Make sure you use metric units. When you then put in charge 1 in coulombs, charge 2 in coulombs, you're multiplying those 3 factors, and then you're dividing by the distance between the two charges in meters squared. So that's Coulomb's law and the way you operate with it. Make sure you use standard metric units for the charge and for the distance between the two charges. One last concept here. The direction of the electric force could be called radial. It's on a line that connects the two charged objects. And again, if we have the same sign of charge, we're going to get a repelling action directly away from each other. So I'll put one positively charged object here. I'll put another one here. This object exerts a force on this object in this direction. This object exerts a force on this object that's in this direction. If they're oppositely signed charges, so plus here and minus here, this object creates an attractive force on this object. This object creates an attractive force on the positively charged object. and those will be the same magnitude arrows. But we get this directly away or directly towards for the direction of the force. Force is a vector, so we need the magnitude. That's supplied by Coulombs Law, KQQ over R squared. And we need a direction, and that direction is always directly repelling or directly attracting towards each other. And you need to keep track of that in a diagram as you seek to work problems involving electric force. So keep reviewing, keep reading your books, and asking questions.